Hello students, let us see today Newton Raphson related problems. Find the real root of x cube minus 2x minus 5 equal to 0 using Newton Raphson method. So the given f of x cube minus 2x minus 5, and just we have to substitute x 0, then we'll get 0, so minus 5, which is negative. Next, we have to substitute x equal to 1. Then we will get 1 minus 2 minus 5. So minus 6, which is negative. Instead of x, we have to substitute 2. So 2 cube 8 minus 2 into 4 minus 5 equal to minus 1, which is again negative. Next, instead of x, we have to substitute 3. Then we'll get 27 minus 6 minus 5. So 16, which is positive. Therefore, a root lies between 2 and 3. So, where it will change the sign, negative to positive or positive to negative, then we have to find out easily roots. So, here, when you are substituting 2, then we'll get negative. When you are substituting x equal to 3, we'll get positive. So, therefore, a root lies between 2 and 3. Therefore, a root lies between 2 and 3. So next write Newton-Raphson formula. So Newton-Raphson formula, xn plus 1 equal to xn minus f of xn divided by f dash of xn. So this is Newton-Raphson formula. If we put n equal to 0, then we'll get the first iteration. So the given f of x equal to x cube minus 2x minus 5. So denominator f dash of xn is this. So you should differentiate with respect to x. Once the given function x cube differentiation 3x square minus 2x differentiation 2. We put n equal to 0, the Newton-Raphson formula, then we'll get first iteration. X naught minus f of x naught divided by f dash of x naught. So here x naught value, your choice, do you want to take average 2 plus 3 divided by 2, 2 plus 3 divided by 2, which is 2.5, or take 2 or 3. You can take any numbers. Any numbers means 2 and 3, or between 2 and 3, to take any numbers. So I am taking here x naught 2. So 2 minus f of 2 divided by f dash of 2. So 2 minus f of 2. F of 2 means already we have f of x. In that f of x, we can substitute instead of x2. Then we'll get 2 cube minus 2 into 2 minus 5 divided by f dash of x. Already we have f dash of x. Instead of x, we have to substitute 2. So 3 into 2 square minus 2. So 2 minus 1 divided by 10. So 2 plus 1 by 10. So this simplify will get x1 equal to 2.1. Next, if we put n equal to 1, then we'll get the formula x2 equal to x1 minus f of x1 divided by f dash of x1. So x1 value here 2.1 minus f of 2.1 divided by f dash of 2.1. So 2.1 f of 2.1 means that given f of x function instead of x you have to substitute 2.1. 2.1 whole cube minus 2 into 2.1 minus 5 divided by 3 into 2.1 whole square minus 2. So 2.1 minus 0.061 divided by 11.23. Using calculator, simplify, then we'll get x2 value 2.0946. Then x values are repeated. Then we have to stop the process. Here x1 value 2.1, x2 value 2.0946. Next we will find out x3 value. The formula, if we put n equal to 2, then we'll get x3. So x3 equal to x2 minus f of x2 divided by f dash of x2. So x2 value 2.0946 minus f of x2 value 2.0946 divided by f dash of 2.0946. So 2.0946 minus. So in the f of x function, we have to substitute instead of x 2.0946. So then we'll get 2.0946 whole cube minus 2 into 2.0946 minus 5 divided by 3 into 2.0946 whole square minus 2 2.0946 minus 0.0005 11.1621. So using calculator simplify, then we'll get 2.0946. So here the exact 4 decimals are repeated, and x2 and x3 exact 4 decimals are repeated. So the better approximate root is 2.0946. Let us see one more problem in Newton-Raphson method. Solved by Newton-Raphson method, a root of e power x minus 4x equal to 0. So it will be mentioned Newton-Raphson method. So you should use Newton-Raphson formula. F of x equal to e power x minus 4x So x, if we put x equal to 0, then we'll get e power 0 minus 4 into 0. We know that e power 0 value 1, so 1, which is positive. Next, we can substitute x equal to 1. So e power 1 minus 4 into 1. This simplify, using calculator simplify this, then we'll get minus 1.2817, so which is negative. So when you are substituting x equal to 0, we'll get positive, and when you are substituting x equal to 1, then we'll get negative. So therefore, a root lies between 0 and 1. 0 and 1. So now we'll take 0 or 1 or zero point 0.5. So write Newton-Raphson formula, xn plus 1 equal to xn minus f of xn divided by f dash of xn. We put n equal to 0, then we'll get first iteration x naught minus f of x naught divided by f dash of x naught. So I'm taking here x naught value. Between 0 to 1, I'm taking x naught value 0 0.3. So here given function e power x minus 4x. We differentiate with respect to x, e power x minus 4. So if we substitute x naught value 0 0.3 minus f of 0 0.3 divided by f dash of 0 0.3. We have f of x and f dash of x. Instead of x, we can substitute 0 0.3, and instead of that f dash of x function, we have to substitute x equal to 0 0.3. Simplify, then we'll get the answer x1 equal to 0 0.3566. Next, find out x2. So x2 equal to x1 minus f of x1 divided by f dash of x1. So x1 0 0.3566 minus f of 0 0.3566 divided by f dash of 0 0.3566. So, as usual, just we have to that f of x function, instead of x, you substitute 0 0.3566, and f dash of x function, you have to substitute instead of x 0 0.3566. Then simplify using calculator. Just you have to simplify. Then we'll get the answer x2 equal to 0 0.3574. Next, to find out x3. So x3 equal to x2 minus f of x2 divided by f dash of x2. So x2 value 0 0.3574 minus f of x2 value 0 0.3574. Instead of we already given function f of x, instead of x, you have to substitute 0 0.3574, and denominator f dash of x2 value 0 0.3574. So using calculator, simplify this, then we'll get the value for x3 0 0.3574. So x2 and x3 both of exact correct to 4 decimals are exactly repeated. So then we have to stop the process. Sometimes will be mentioned given the problem 5 decimal repeated, 4 decimal repeated. So until you have to do it, So here exact four decimals are repeated. So then we have to stop the process. So hence the better approximate root is 0.3574. So given any problem in Newton-Raphson method, first you should write the given function. Instead of x, you have to substitute 0, 1, 2, 3, where it will change the sign. Then you have to stop the process. You should find out the roots. For example, the first problem, when you are substituting x equal to 2, we are getting negative. When you are substituting x equal to 3, we are getting positive. So therefore, a root lies between 2 and 3. So I am taking here x naught value 2 by Newton-Raphson formula and write given f of x and differentiate once with respect to x because Newton-Raphson denominator formula f dash of x in. So you should differentiate once with respect to x. So if you put n equal to 0, then you get first iteration. Instead of x naught, we can substitute 2 or 3 or 2.5, 2.3 or between 2 to 3, you can substitute any number. So our choice. So simplify, then you get the answer 2.1. Similarly, you have to continue the process. When exact four decimals are repeated, then we have to stop the process. Here x2 and x3 exact four decimals are repeated. So then we have to stop the process. Thank you, students.